Today we're working on the first page of the fourth set of notes, and the focus is on solving polynomial equations with a focus on the sum and difference of cubes. So first thing I would like to give you is the formulas. You do not need to memorize these for the test. However, when you take the park in March and May, they will not give you these formulas. So I highly recommend you memorize them now. You will not have to memorize them for the test, but when you take the park, you will have to know them by memory. So very similar to the difference of cubes, or the difference of squares, now we have formulas for the difference of cubes. And the formula says if you have a cubed plus b cubed, then you have a plus b as your binomial, and the trinomial will be a squared minus ab plus b squared. Similarly, the difference of cubes will be a minus b times the trinomial of a squared plus ab plus b squared. So as long as you can identify a and b, it's just a matter of substituting it into the formula. Something I want to go over before we do these examples is our perfect cubes, and I'm only going to expect you to know up to 5. So your perfect cubes, so 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64, and 5 cubed is 125. So I'm only going to expect you to know up to 5. Obviously, you could always figure them out at any time, just like we know our perfect squares are 1, 4, 9, 16, 25. These are key values that should stick out to us because these are our perfect cubes. So going back to the examples, so here's example 1, and we need to be able to identify my a value and my b value. So a is going to be x, because x times x times x gives me the x cubed. My 8 can be rewritten as 2. 2 times 2 times 2 gives me the 8 value. Now I look at the formula. Since this is subtracting, I'm using the difference of cubes, and now it's just a matter of substituting in the values. So the formula says it's going to be a minus b, so x minus 2, times the trinomial of a squared, which will be x squared, plus a times b, which will be 2x, plus b squared. So 2 squared would be 4. Final answer. So let's try another one. So here we have 8x cubed plus 1. I think on your paper it says minus 1. We're going to change it to a plus 1. Again, being able to identify a and b. So 8, the perfect square or perfect cubed of 8 is 2, and since I have a variable of x, I'm going to say it's 2x. To check yourself, 2x times 2x times 2x gives me 8x cubed. My value of 1 is still going to remain 1. 1 times 1 times 1 is the 1 cubed. So there's my a and b values, essentially the perfect cubed of those original two. Now it's just a matter of plugging into the formula. So the formula says a plus b, so 2x plus 1, times the quantity of a squared. So my a is 2x, so a 2x squared will become a 4x squared. 2x times 2x is 4x squared, minus a times b, so minus 2x, plus b squared, plus 1. Again, done, final answer. Hardest part is identifying the a and the b. So we will practice that again a little bit more in class. So now I'm going to show you how to actually apply this to solving a problem. Notice, can't use factoring by grouping because I don't have 4 terms. I can't take a GCF out, there's nothing in common. I can't factor, so the only option is the sum of cubes. So we're going to start by identifying a and b. So 27, the perfect cube of 27 would be 3. So my a is 3x. 3x times 3x times 3x gives me the 27x cubed. And my b is 1. So this is the sum of cubes. So I have a 3x plus 1, that's my a plus b value, times the quantity of my a squared. So my 3x, the quantity of 3x squared will be 9x squared, minus a times b, so minus 3x, plus b squared, so plus 1. Now notice it's equal to 0, so I would like you to actually solve. If I check to see if it's factorable, 9 times 1 is 9. Nothing multiplies to be 9 and adds to be negative 3. So this is not factorable. It is still solvable though. So to solve, we need to use quadratic formula. So now we're going to identify a new set of A, B, and C. A is 9, B is negative 3, and C is 1. So these three values are coming from that trinomial right there. So now we're going to use quadratic formula. Quadratic formula is my negative b plus or minus the square root of my b squared minus 4 times a times c all over 2 times a. And again, we've talked about we take our square root value off to the side and we figure that out. Still applies here. So I'm going to take this off to the side. I'll have 9 minus 36. So the square root of, let's see, a negative 27. And this will break down to be 9 and 3. So the square root of negative 27 is 3i square root 3. Take that back into the problem. So my first part becomes positive 3 plus or minus 3i root 3 all over 18. And since all three outside values are multiples of 3, I can reduce it. So this final answer becomes 1 plus or minus I root 3 over 6. So there's 2 of my answers. The last place where we get our third answer from would be my quantity right here. This binomial gets set equal to 0, and if I set that equal to 0 and solved, I'll have 3x plus 1, set that equal to 0, minus 1, 3x equals negative 1. So my third answer is negative 1/3. So here are my 3 answers. 2 are from the quadratic formula, and 1 was from that binomial. So we're going to pick up with this tomorrow and practice more of these.